Good afternoon, guys. Welcome to lesson 11.8, equations of circles. Today's learning objective is I can write the equation of a circle given its center and radius. Now, we have plotted other things on the coordinate plane. We have not talked about circles yet. Today is our day. So first off, equations of a circle. The circle general rule for an equation is parentheses x minus h squared plus y minus k squared equals r squared, where h and k is the center and r is the radius. So this h and k in here is just the center of my circle, a point that's being given to me, and r is my radius. Now, you're going to tell me, why isn't the center x and y? Well, because I already have x and y, and sometimes we're going to have to solve for that. You'll see in a minute. But in general, this is going to be the easiest way to denote that. So I'm going to leave this up here. I'm going to get rid of this, though, because that formula, though, it's going to help us as we keep going. And you can look back up at the top of your page, but I can't. So for the first example, it says write the equation of a circle whose center is at 5, -6 and has a radius of 12. So I'm going to take my pen. The center is at 5, -6. So I'm going to substitute that in for h and k. So h is this 5, k is that -6. When I substitute it in, I'm going to get x minus 5 squared plus y minus -6 squared equals r, or 12 squared. Now, that is not in the prettiest form, I would say, and it's not a form that you're going to see it in most often. If I have a negative and a negative, remember that a minus and negative is the same thing as adding a positive, so that's one big plus. And I can also simplify this 12 squared, so I'm going to do that right here in red. The final form that you would see on a test or quiz or, worksheets going forward is x minus 5 squared plus y plus 6 squared equals 144. Now, does that form kind of look familiar to you? Well, the form might not, but if you think about these being like opposite, see how when they are outside here, they're opposite, so 5 and -6 instead of -5 and +6 almost? That kind of relates back to transformations that you guys did last year in Algebra 1. For the next one, I'm going to do the same thing, and I am going to skip this minus, okay, and just go straight to the plus. So here I've got x minus -5, which is the same as plus 5 squared, plus y minus -3, which again is plus 3 squared equals, and now I have -6, or excuse me, the square root of 6 squared. Well, again, that's not exactly how we would see it. The square root of 6 squared is just 6. So that's how I'm going to write this. The square root of 6 squared is 6. So that would be the final form right there. All right, continuing down my page, I've got 3 and then these nice ones at 4 and 5. So 3, I've got all positives. Oh, there we go. I've got all positives, but I have a 0 here. So that gives me a little bit of a special case. So again, x minus my first coordinate squared plus, and then I'm going to do y minus 0 squared. Well, my minus 0 is just y, right? So I'm just going to write y squared. And then equals 7 squared, or 49. That would be in my final form. For 4 and 5, I'm given graphs and I need to find the equation. So again, to have an equation, I need a center and a radius. So I'm going to first identify my center and my radius. Well, the center of this is already nicely labeled for me at -2, +4. My radius I can figure out by counting my boxes is 2. So that means I can substitute in parentheses x plus 2 squared plus parenthesis y minus 4 squared equals 2 squared, or 4. 5, you're going to do the same way. My center in this case is 0, negative 2. My radius is positive 3. So my equation is x minus 0 squared. Remember what I said up here? I don't really want to write x minus 0 squared. It's just not super pretty. So instead of writing that, I'm just going to keep that as x squared. I'm going to move that squared a little closer. So I'm going to just write x squared because of like what we did up above. So x squared plus y plus 2 squared equals 3 squared, or 9. All right, going down, or flipping your page, I guess. Now we're going to give you the equation, and you got to tell me the radius in the center. Again, like a transformation, these two things are getting switched, or their signs are seemingly switched. So my center, even though it looks like it should be at positive 2, negative 6, or positive 12, negative 4, it's really at negative 12, positive 4. And my radius is the square root of that number, 81, which in this case is 9. Looking at 7, again, this is going to be its opposite. So negative 7 is my x value. My y value, I don't have one written, but remember up above, that means that it's just 0. And my radius is the square root of 21, or it's a decimal, but that decimal doesn't really mean a whole lot to me, so I'm just going to leave it as the square root of 21. Going down to 8 and 9, we're going to need to graph these. Now, we have not graphed any circles yet. Obviously, we're just getting to circles now. But the first thing we're going to need to do is the same as we did up above, is identify a center and a radius to graph it. So my center, again, negative 1, positive 2. And my radius is the square root of 16, or 4. So the first thing I'm going to do is draw my center, negative 1, positive 2. Negative 1, positive 2. Man, Miss Simons. Okay, there we go. Negative 1, positive 2. And a radius of 4. So I'm going to go up, down, left, and right 4. So 1, 2, 3, 4. There's going to be a point. Oh, it's a very big point. 1, 2, 3, 4. Here's another point. 1, 2, 3, 4. And finally, all the way down here. Now, am I going to ask you to try to count this way? No, this point, I don't think actually should be on your circle. But what you can do right now is sketch in where this circle will go. Now, I'm on a computer. As long as it doesn't look like a diamond, I'm good. Make it arced. Remember how when you guys did parabolas, they had to be arced? Make sure they're arced. All right. Over here, 9, same idea, center. I don't have an x coordinate written, so it's 0. My y looks like it's going to be negative 3, so it switches, it's positive 3. My radius is the square root of 9, or 3. So again, 0, positive 3. Here's my center point. I'm going to go 3 out in every direction. Perpendicular directions, I should say. And then connect those with like an arced line. This right here is not gorgeous, but you're going to have to forgive me because I'm on a computer. Ten says to write the equation with a center that passes through a point. This one is tricky. So first of all, I'm going to write the equation of a general circle right here for us to refer back to and talk about the parts. So it's x minus h squared plus y minus k squared equals r squared, where h and k are my center. So if h and k are my center, then I already can substitute those in. So I'm going to do that over here. I'm just going to leave some blanks where everything else is because I don't have a radius. I'm going to leave some blanks and I'm just going to put in everything except for my center. So x I'm going to leave, and then minus 3 squared plus, I'm not going to write y, I'm going to leave that blank, minus 10 squared equals, and I don't have a radius, squared. Okay, well, I definitely don't have a radius. But what I can have, or what I do have, what I can do is take my point here, 12, 12, and put it in for x and y. So I'm going to do that right now. I'm going to put that in for x and y, just like when we solve for a point on a line. Given a point, so 12 and 12. And now I can just simplify this. So 12 minus 3 is 9 squared, plus 12 minus 10 is 2 squared equals r squared. That would give me 81 plus 4 equal to r squared, which means that 85 is equal to r squared. Now, I could go further right now and write that must mean that r is the square root of 85, but if I need to write an equation of a circle, it doesn't matter that much to me, so I'm not going to bother with that. But what I am going to do is substitute back in right here for that r squared. And where it says 12, 12, I'm going to leave that as x and y again. So now I can put these back. H is still 3. K is 10, and now my r squared, the full thing, is 85. So here, I'm writing it backwards, is the equation of that circle. X minus 3 squared plus y minus 10 squared equals 85. Last, I'm going to scroll because I'm going to need some space for this. This is what we're really getting into tomorrow, but if you want to extend your thinking a little bit, this is really important. I have this equation. Now, remember that my form is x minus h squared plus y minus k squared equals r squared. You might be able to right now think that you can identify the radius. You actually, in this case, you can. Because right now, if I look, here are all my x's. Here are all my y's. Looking at my x's, can I rewrite this as a perfect square? That's what that means. And I can. My perfect square for this, if I were to factor this out, I would get x plus 1 times x plus 1, which is the same as x plus 1 squared. My y's, if I'm looking for factors of 4 that add to 4, it would be y plus 2 times y plus 2. Or y, parentheses, y plus 2 squared equal to that r squared. So can I identify my center and my radius? Yeah, my center is at -1, -2, and my radius is 11. All right, guys, more with completing the square tomorrow, which is really just this part right here, and factoring, but we're going to do more of that in tomorrow's lesson. Have a good night. I'll see you tomorrow.